everybody, Brian here from quantlabs.net. Okay, so just want to give you a brief introduction into the Intel TBB, better known as the threading building blocks, open source library for concurrency, parallelization, multi-core. Now, I put up a video or a posting yesterday regarding some notes on the TBB, some tutorials, and some other stuff. So what I'm going to show you is why TBB. Okay, so originally, if you have been following me, I've always liked FastFlow. FastFlow looked good until I asked a simple question on the FastFlow email list. And basically what I got was, it was just because one of their builds for Mac was failing and I was looking for help. First, the response was rejected by the administrator, and then just basically check out this. Well, being an idiot, I'm not an idiot, I don't know, I do follow instructions and it didn't work, so screw them. So here we are with Intel TBB, and I kind of thinking it might have been a better choice. So I put a bunch of notes together. It's put up by Intel, a proper vendor behind the project. I'm not going to show you basically the how it works and what it does, but as you know, I put up basically you can download all it in Windows, Linux, OS 10, and all of these will run with a proper IDE file, source file, so you can load it up in my case Xcode on OS 10 on Mac. So what I want to show you is a couple things. First is the Xcode project. Now, basically, there's different ways to go about building out your concurrency pattern, I guess you could call it. So what we're doing here in this one is using the flow graph, and really the reason I'm using graphs and flows instead of their other ones is I want to talk about Goldman Sachs. They have an internal database called SecDB, SecDB. Not a lot of people know about it, but it's an enterprise level database that's internal to Goldman Sachs. And any trade, probably automated and human generated, has to go through the database called SecDB. And basically what it is, it will run all the analytics against their portfolio and risk. And every single trade has to be run through this database. And that database keeps their portfolio, over their whole portfolio, in line and make sure that there's no rogue trading. Now, from what I understand, in 2008 and 9, this SecDB is very old. It's been around for probably decades. But with SecDB, the database basically saved Goldman Sachs in 2008-9 when they were going into a meltdown, or could have gone into a meltdown. But that database, because of their risk assessment, their risk management enabled them to basically be saved. And this type of database, as you can see, is based on graphs. Okay, it's a different way of building out concurrency design patterns. And it's kind of like a different way of an algorithm with edges and stuff. I'm not going to get into that. But anyways, what we have here is very similar to what I wanted to do with Simulink back in the day, a few years ago, where you have your input. In this case, it could be a stream of data or ticks. You run it through some kind of process where each one of these is a worker, a node worker. And if you've studied the FastFlow, it's very similar. So each of these is a worker. In this case, is a square and a cuber. So it's basically an algorithm. And here in the join, it will just basically summarize both the results of the square and the cuber, and then here at the end you can make a decision at the end. So let me just see if my latest video got rendered okay. So I want to show you something. I just put up a new video. And
hey there, how's your trading going?
Alright, so yeah, here it is. So this video here called Quick Demo of Intel TBB C++ Flow Graph Designer Code Generation and all that. Basically, if you Google that, TBB Flow Graph Designer, this is a tool I'm referring to, and you can download it for free, but it's only available for Windows. So I've got a video on that showing you what it can do. And here's all the cool stuff with it. That's cool. So going back to that, what I just want to show you, this pattern here. So we basically have our two algorithms, our two workers. So essentially similar to what SecDB does, we have as many algorithms as we want here in these nodes, or I call them workers, because that's kind of what they are. And you can run them in parallel, and you can have even ones that focus on risk management, risk assessment, and the end here you can have it basically make a trading decision and put on a position. So let me show what I'm trying to do here. So if you come into here, let me just see if I can freeze it. Okay, right here, I'm gonna put it to full page mode. Okay, so right here it's very similar. So this is flow graph designer, obviously. Here's our input. We can input, in our case, hopefully you've seen my video on Redis and how you can do what they call pub/sub, publisher subscriber. So here you could have your pub/sub code, and when there's an event, when a new tick comes in, you can add it, kick off this process right here, and then have it analyze using these workers or nodes, where each one would be an algorithm. And as I said, you can have as many as you want. And then basically collect the output here, so you could have it weighted based upon these results. And then here have a trading decision. And if it says yes or no, put on a position, then you just say, okay, throw it into a Redis collection, position collection, let's say, and add it to that position, set of positions, so another set of processes will watch those positions. So hopefully you get the idea of what I'm thinking here. Very similar to what I was wanting to originally do in Simulink, MATLAB Simulink, but that was probably thousands upon thousands of dollars that nobody could really afford. And the other beauty part about this is later on, if you look at the code, there is a way you can generate generate code. Just watch this video and you'll see what I mean. So let's get to here. So this is an example of the code. Okay. Now again, this is on Windows, this tool, but you can still create your stub code and basically load it up in your IDE. For me, I want to do it on Mac using Xcode as my IDE. But here's an example set of code that I copied from here and put in my Xcode. So, like I said, what we're doing here is here's the code. So let me just go into Xcode and show you what I mean. So this is a typical project you can download as one of the examples, but I just commented everything out and just threw in this simple code here from that site of that example code. So that's all I did. I'm just being kind of lazy here. And basically what it does is it will run, so I can run it no problem. And here's the output right here. Build succeeded, here's the output. So basically what it's doing is, here's the two algorithms. So we have here I think these are structures, an operator, blah, 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 blah. Yeah, so these are your algorithms right here. So this is a squaring, This is the cubing right here, so you could have in whatever you want in this code as a function. But of course, Intel, part of their documentation for the TBB says you got to make sure it's really efficient, and they got a spec on how to create these functions, these operator nodes. So once we've run the square, the cuber, we join it, and basically what we're doing is we're just adding the two together, the results of the square and the cuber, and that's what this does, right? And from there, this is the actual code to set it all up. So from what I understand, we set up a graph, we broadcast it, and here we've got our two functions, basically our nodes that we're setting up, function node, and then at the end we have this tuple with the resulting code, which is basically, as I said, this join right here, and we are summarizing them right here using the summarizer. Now in this case, I think it runs it once. No, and then what we gotta do is we gotta set up each edge, which is part of a graph. So we gotta set up this, 5 edges basically. So we got 1, 2, 3, 4, 5. Yeah. So we've got our input, square function, cuber function, and the joint, and those are each an edge. And then what it does, it runs it in a loop times 10 times, and it basically will run. And then this basically means once it's complete, run it again. And this is where all the parallelism comes in. So I got a lot to learn here, but it can be done. It's fairly straightforward once you understand the concept here. And then, as I said, you can use that as an entire system. So at the end here, based upon our summary, our final result, you can maybe weight each algorithm, somehow prioritize it, and then with a certain result, put on a position, don't put on a position. Just my thinking here. So this is, again, all in C++. That's pretty cool. And you can make it as sophisticated as you want. And again, you can use this flow graph designer to you watch this video, you can create some very sophisticated code from this tool. So I just wanted to show you this. This is a great tool, it seems, and library to use for parallelism, multi-core, concurrency, all 100% C++. So I just want to show that to you. And, as I said, with the note here about how FastFlow has rejected my query, that's cool. Blessing in disguise, as I would call it, which became how I looked into Intel TBB, and actually is better than FastFlow with these kind of tools. And the backing of Intel makes it a lot more professional and worthy to work with, especially with this flow graph concept of what they have in C++. So basically what I'm intending to do is to use this for all my trading quote-unquote systems. Not end-to-end, but at least the first half, to be able to stream data in and then be able to have a bunch of algorithms in parallel, calculate from the stream, and make a trading decision based on that. So that's the whole point of it. Hopefully you're with me and you understand what I'm trying to do here. Talk to you later.